Alrighty, hi everyone, and welcome to Week 13's Module 5, Chapter 7, PowerPoint and Video Lesson Presentation. My name is Toni Breshears. Now let's get started. Okay, so how to convert decimals as fractions in lowest terms and how to find prime factorization. So we're going to start out with 0.225. So first we divide the decimal by 1, and it gives us 0.225 over 1. Now multiply both top and bottom by 10 for every number after the decimal point. So we have three numbers after our decimal point. And so we would come to 225 over 1,000. And so now we simplify. So 225 over 1,000 divided by 5 equals 45 over 200. We divide by 5 again, and it gives us 9 over 40. So how to find the prime factorization using the prime factor tree. Okay, so we'll start out with our little grid here. Okay, so we'll do 225, and using prime numbers, we'll do 3. So 225 divided by 3 is 75, and then you do 75 divided by 3 is 25, and then 25, which is, you can get 5 times 5 equals 25. So our prime factorization is 3 times 3 times 5 times 5. Okay, so now on to 0.036. We're going to be doing the same thing. So we divide the decimal by 1, and then, which is 0.036 over 1. And then now multiply both top and bottom by 10 for every number after the decimal point. So we have our 0, we have our 3, and we have our 6. And so 36 over 1,000. Now we simplify. So 36 over 1,000 divided by 4 equals 9 over 250. So how to find the prime factorization using the prime factor tree. So we take 36 and 36 divided by 2 is 18. 18 divided by 2 is 9. And then 9 divided by 3 is 3. So our prime factorization is 2 times 2 times 3 times 3. Or 2 to the second power times 3 to the second power. Okay, so now on to our next problem. Plotting formulas on a graph. Okay, so y equals x over 2. Your mom takes you to the store and tells you that you can buy some candy, but you must split half of your candy with your little sister. There are bags of candy with 8 pieces, 10 pieces, 14 pieces, and 20 pieces. How many pieces of candy would you get to yourself if you bought one of these bags of candy? So, if you bought 0 bags of candy, you would get 0 pieces of candy to yourself because there'd be no candy to split in half. If you bought the bag that had 8 pieces, you would have to give out half, and that would give you 4. 10 pieces would give you 5 to yourself, and the other 5 would go to your sister. 14 would give you 7, and then 20 would give you 10. So over here, now we have it plotted on a graph. So that way, if you want to know how many pieces of candy you would get with your 10, you'd go over here on your x-axis, and you would find your 10, and you'd go up, and it's in between your 4 and your 6, so you would get 5. Graphs are a great way to plot your data, as well as a table graph to show your data within the line graph. Okay, so next one. Okay, so y equals negative x over 2. So you're on a path to losing weight, and you have read that for every 30 minutes of exercise, you lose half that amount in weight. So how much weight would you lose if you worked out for 3 hours, which is a total of 180 minutes? So you practically lose, however many minutes you work out, you practically lose half of the weight in minutes. So let's see. Okay, so if you worked out for 0 minutes, you would lose 0 pounds. If you worked out for 30 minutes, you would lose 15 pounds. If you worked out for, these are your minutes down here. So if you worked out 30 minutes, you'd lose 15 pounds. If you worked out for 60 minutes, you'd lose 30 pounds. If you worked out for 90 minutes, you'd lose 45 pounds. 120 minutes, you'd lose 60. And then 150, you go over here on your graph and you go all the way up and you would lose 75 pounds. And then on 180, you would lose 90 pounds. Okay, so on to our next one. So y equals 10x. So your local shoe store is having a sale where each pair of shoes is only $10 throughout the entire store. How much would it cost if you bought 5 pairs of shoes? Okay, so our x is going to be the amount of shoes, the amount of pairs of shoes you buy, and then our y is going to be how much it costs in total. So if you buy 0 shoes, it's not going to cost you anything. If you buy 1 pair of shoes, then it'll cost you $10. 2 pairs of shoes, $20. 3 pair, $30. 4 pair, $40. 5 pair, $50. 6 pair, $60. So now this is what our graph would look like if we made it according to that table. So as you can see, our pairs of shoes is our x-axis and our prices of shoes is our y-axis. So 1 pair of shoes is $10. 2 pairs of shoes is 20, 3 is 30, 4 is 40, 5 is 50, 6 is 60, and so on and so forth. All right, on to our next question. Percentages and fractions. Okay, so we are given here a square that is split up into 4 different parts. But it wants us to find out what fraction of our square is taken up with what this yellow triangle takes up. So we can see that our square is split up into 4 equal parts, but the triangle is only half of one of those equal parts. So what we have to do is split up our square into an equal amount of parts, such as the yellow triangle. So I went and split everything in half to equal the yellow triangle to make our fraction, finding our fraction a tad bit easier. So as you can see, the triangle is 1, 2, 3, 4, 5, 6, 7, and 8. It is one of 8 pieces. So 1 divided by 8 equals 0.125. And then you count how many, to find your percentage, you count how many decimal places there are after the decimal. So there's 3. So you do 125 divided by 1,000. And then that will give you 12.5%. So that is how much that small triangle takes up of the one whole piece. All right. And then now, this one's a bit more confusing because every shape that is blue, that is how much they're wanting us to find of our whole. But you see that we have 3 squares that are blue, but we have 1 triangle that's blue, but our whole piece is made up of squares. So what you have to do is split everything evenly to fit where we can find our fraction in a much easier way. So I split everything in half. So now our squares match the same shape as our 1 triangle. So if you count, our squares and our 1 triangle make up 7/18 of our whole. So 7 divided by 18 is 0.39, and then you count your decimal places. There's 1 and 2 decimal places. So it's 39 divided by 100, and that gives you 39%. All right, on to our next one. Okay, so as you can see here, we have a circle with a red shape in it. Now, the red shape, you can see, is the same as the white shape. So if they're both the same shape, same size inside the circle, then the red is only taking up half. Since there's only 2 pieces, it is only taking up half of the circle. So it is taking up 1/2. So 1 divided by 2 is 0.5. And then you count your decimal places. It would be 0.50, but 50 divided by 100 gives you 50%. Half is 50%. So that concludes that. Okay, finding the percent of a fraction. Okay, so we have percentages up here at the top, and as I continue, you will see where those come into effect. We're going to try to find what percentages fit with what fractions. So, okay, so here you see we have 1 triangle. And now we have a hexagon. So our hexagon, we have to see how many triangles will fit into our 1 whole of a hexagon. So as we split it up, it shows that 6 triangles will go into this one hexagon. So that triangle is 1/6. So 1 divided by 6 is 0.167, and then you multiply that by 100, and that gives you 16.67. So the fraction is 1/6, but when you multiply it by your 100, you get 16.67%. So that is your percentage of the one triangle inside the hexagon. Okay, now we have a rhombus. And it shows that, as you can see, there's only 3 inside. Well, this is a diamond. It only shows that there are 3 diamonds inside the hexagon. But if you look closely, if you were to flip these the other ways, these are just triangles. So if you were to flip these the other way, it would show that you would have 1, 2, 3, and then that's an end, that's an end. So that makes up 4, that's an end, that's an end, and that makes up 5. So you potentially have about 5 rhombuses inside your hexagon. So 1/5, which is 0.2, 1 divided by 5 is 0.2, and then times that by 100, and you have 19.2%. It is approximately. That is why you see the 6 triangles, it equals. It is exactly. But because we're not so sure if exactly 5 rhombuses make up the hexagon, then we have an approximate symbol here instead of an equals. Okay, so now we're going to try our parallelogram. Okay, so what you see here is we have one parallelogram, and we have to find out how many parallelograms make up our one hexagon. So as you can see is we've got 1, 2, and 3. So 3 rhombuses, well, parallelograms, make up 1/3. One of these make up 1/3 of our hexagon. So when you divide, 1 divided by 3 is it's 0.333. So when you multiply that by 100, you get 33.3%. So now onto our squares. How many squares can fit inside this one hexagon? So when you look at it, we see that there's 1 and 2. But if you cut this in half, that is it's like a triangle. So we have these triangular shapes over here. So it could approximately, because 2 triangles can make up 1 square, and we have 2 triangles here, we approximately have 3 squares that could fit into this hexagon. So we'll say 1 square is 1/3. So it is approximately 0.333. It's approximately 1.385. So 1.385 times 100 is 38.5%. So let's go on to our next one. Okay, so now we have a trapezoid. How many trapezoids will fit inside this hexagon? So one trapezoid takes up half of a hexagon. So if we had 2 trapezoids, then it would make a whole. So 1 is half. So 1/2, 1 divided by 2 equals 0.5 times 100. When you multiply it by 100, you get 50%. So one trapezoid is 50% of a whole hexagon. All right, so now on to our word problem. Okay, so I bought 10 Santa hats to take to my daughter's Christmas party for her classmates. Only 6 out of the 10 students, including my daughter, were present, so I only had to give out 6 of the hats. What percent of the hats did I give out to the students? Okay, so here we have our 10 Santa hats. Okay, so showing over here, we have 10 hats. The hats given were 6. And so this is just showing how many of the hats that we took that I gave out was 6. Now, fraction form. So if I give out 6 of my 10 hats, that's 6 out of 10. So 6 over 10 times 10 gives you 60 of 100. So usually when we put things over 100, it's automatically a percentage of itself. So 60% of the hats were given out to the students. because when you do 60 over 100, that is 60% out of your whole, out of your percentage. Okay, so 60% of the hats were given out to students. Now, say I still have the same 10 Santa hats that I bought to take to my daughter's Christmas party for her classmates. But now a teacher asked if I could give up 50% of the Santa hats for the other teachers to wear. If I give up 50% of the hats, how many hats am I giving to the teachers? So I still have my same 10 hats, but different scenario. Okay, so hats are 10. The percentage that I give is 50. So 50% equals 50 over 100, which equals 1/2. And so if you take how many we have and put them over 2, 10 divided by 2 gives you 5. So I gave away 5 of my Santa hats to 10 of the teachers. Not 10 of the teachers. I gave away 5 of my Santa hats out of 10 of my Santa hats to the teachers. All right, so now with Christmas around the corner, I feel like giving more than just 50% of my hats away. I decided to give away 90% of my hats, which is equal to 9 of my hats. If I give away 9 of my hats, how many did I have in total? Okay, so hats. I've given away 9, but percentage, I gave away 90% of my 100%. So what we do is if you take the 90% and turn it into a decimal, then that gives you 0.9. Divide 0.9 by the amount of hats given to find out how many hats I had to begin with. So if you take 0.9 divided by 9, that equals 10. So it shows that I had 10 hats to begin with. Okay, I'm having a dinner party tonight and want to make macaroni and cheese. Each box contains only 3 servings, but I am having over 30 guests. For each guest to have 1 serving each, how many boxes do I need? Okay, so first you have to make a table. If each box has 3 servings, how many boxes will I need to get the 30 servings that I need for my guests? Okay, so if you have 0 boxes, you have 0 servings. If you have 1, you've got 3. 2 is 6. 3 boxes will give you 9. 4 will give you 12 servings. 5 will give you 15. 6 is 18. 7 is 21. 8 is 24. 9 is 27. And 10 boxes gives you 30. So just by our table, we can already see that I will need 10 boxes of macaroni and cheese to feed my 30 guests. So they'll all at least get 1 serving. And so this is how it would look on a line chart. So here on my x-axis, we have the boxes of macaroni. And then here on my y-axis, we have servings. So if you look at our points, you would plot your 0, 0, and then here in between 0 and 2, we'll have 1. And so that'll be our 3. 2 is 6. 3 is 9. 4 is 12. 5 is 15. And 6 is 18, and so on and so forth. So that is how you plot your points, and then the table is how you find how many boxes you'll potentially need. And the graph can also show how many boxes you'll potentially need if you would just use that and work your way up. But, all right. Well, that concludes my presentation for today. Thank you all. I hope you learned a lot. See you next time.